All right, the last little bit we have here, guys and girls, is organs. I'm not going to go over this too awful much, but remember, organs are formed by the interaction by two or more tissues. Okay, obviously, the vast, good lord, all of the organs that you guys looked at last semester, in or last time you took anatomy, everything is comprised of more than one type of tissue. Okay, and when those things interact, working for a common goal, ta-da, that gets you an organ. Skin is an example. We have the epidermis. It is epithelial tissue. We have the dermis, which is a multitude of various different connective tissues. And then we have the hypodermis, which technically is not part of the skin, but it's there interacting with it, so they throw it in here with it, and it's fat. So, I mean, we have muscle, we have various types of epithelial tissues scattered throughout the dermis. So there are a number of different tissue types here, all working for a common goal, all trying to do the best function that it can do to protect, obviously, the skin. To inform you, there's nervous tissue within there, receptors, telling you if something's touching you, or if your skin's cold or too hot. Increasing proprioceptive input with that muscle there. Supplying the tissue there with some small, very small capillaries, various different sweat glands. So there's a whole number of functionalities there. Making vitamin D, all sorts of fun, fantastic stuff there. We're probably not going to get too much into embryology stuff. We just, for one, don't have the time. And two, is just that's an embryology class. But there are three major levels of it. You should kind of be aware, I guess, these terms. So I'm assuming that's why they introduced them to you here. But ecto is the outermost layer, and these layers manifest after the zygote divides and divides and divides and divides. It comes various different things, names. But then you're just this big kind of circular tube of cells. Okay. And that circular tube of cells is comprised of three different layers: outer, middle, and inner. Okay. This outer layer is pretty much giving rise to the skin and to the nervous tissue. The mesoderm gives rise to basically some connective tissue and muscles. And the endoderm gives rise to basically organs. So it is from these three layers that everything pops up from. And it is fascinating as all heck to think that everything that we have, everything that you see in the mirror, everything inside of us that we have, comes from just these three little things. And if you want to go really deep, I mean, comparing how organisms undergo development in utero, there's a ton of similarities between a lot of us, various different organisms throughout the animal kingdom. Truly fascinating. Embryology is just a truly fascinating class if you ever get to take it. I should have just taken this out. We have a couple different types of stem cells, and there are ones called adult stem cells. Adult stem cells give rise to the structures that we have. Okay, stem cells that give rise to bone, cartilage, kidney cells, liver cells, whatever. There's another type of stem cell called embryonic stem cell, and that's pluripotential. And pluripotential means it can become anything with the right stimulus. If you're looking at stem cells and which ones are better, embryonic stem cells are obviously better. Okay, they have less potential defects, and by defects I just mean an adult stem cell. It's been dividing. I mean, you've been growing from a wee person, right, as an infant all the way up to what you are now. So obviously these cells have divided off of and given you new cells. They're narrowed at this point because an osteoprogenitor cell is shockingly only going to become bone cell. It's not going to become liver. And these things have been divided off of. So there is a potential defect, right? Anytime a cell divides, there is a chance that it could have screwed up. So if you're going to have issues with a cancerous line of stem cells, obviously adult stem cell would be the one that you would have issues with. From a legislative standpoint, research using adult stem cells and embryonic stem cells, hoy vey, it's crazy the amount of legislation that there is regulating research using stem cells. Even the amount of money that you have to, I think it's hundreds of millions of dollars to apply to get a license to do some research in these fields. So it's pretty fascinating in terms of what these things can actually do, and really ultimately the slippery slope. It's a great topic for debate. So whether or not you want to use them or not use them, usually it's always for the good of health and humankind, but that always devolves into where's the line? What's disease? And all of a sudden you're coding for blue eyes only, and only robust musculature, and yada yada yada. And there's the slippery slope. There's a couple of stem cell facilities overseas. One I think in the Ukraine, and they have a ton of research out too on it, which is interesting. But their rules are a little bit lax over in Russia or Ukraine. So I don't know if there's one in Mexico or not. I don't know. I can't remember off the top of my head. But there's a ton of research from that one research place in the Ukraine, or one facility in the Ukraine, that has rejuvenation stuff that you can buy. A ton of Americans go over there. Shocking. What are organ systems? You know it. Here they all are. I'm not going to get into it. We're going to dive into them. You've already looked at them. You know what the heck they are. Excuse me. And then don't worry about slide 61, okay? I'm not going to ask you about this yet. We'll talk about fluid components later when we get into those respective systems where that's going to be really, truly important.